All right, we're going to study polynomials. We're going to dissect this word really quick before we start, and this is the section 6.2. We have this word nomials at the end, or the suffix, and that means terms.
Doesn't it mean like terms or something?
They don't have to be like, but they does mean terms. And as in like 2x is a term and 5y is another term. If I add them together, it becomes each one of those were a polynomial in itself, but then when we put it together, it even becomes a bigger polynomial. The word poly, or the prefix poly, means many. Has anybody heard a word with the word poly at the beginning?
Polyester.
Polygon. Polyester. Yes, I bet that means many esters because ester is a type of chemical.
Yep.
Yeah, and so polygon. Gon means sides. Poly means many sides. And there's a group of islands. Say that again.
Yeah, polytheistic.
Polytheistic, many gods. Exactly. All that has the many at the beginning. I was on the island of Guam for many years, and it's not in that particular group of islands, but next door is a group of islands called Polynesia. Nesia means islands, poly means many. I was in Micronesia, and micro means little. I was on little islands. So, but poly here, if we can dissect the words, we can figure out what they mean. So we have polynomials, many terms. And so we're going to talk about polynomials here. What's a polynomial? And there's a true definition of it. You can write this down if you need to, but you'll need to know, I'll tell you the exact things because you're going to actually get some things and say, is this a polynomial or not? So I'll tell you what parts are the things you really need to put down in some way on your paper. It's a function that has one variable. How many variables? One variable. That's important. Now, it can have you can have an x multiple times in that, but it can only have an x. It can have an x and a z and an h and a q. It can only have one of them. But x, like 2x plus 5x, that's okay to have the x two times because it's only one variable, all right? We have one variable, and there are powers of that variable, meaning exponents, and all the powers are positive integers. So if I had 2x squared plus 5x plus 7, this has one variable. It has an x, not x and y or x and z. And one of them has a power, and that's okay because that power is positive and it's an integer. What is an integer? We studied this long ago. What is not an integer? Can you tell me something that's not an integer?
A negative number?
Negative numbers are integers.
What about halves?
Halves, fractions are not integers. What about other things? Decimals are not. Stuff like pi, which would be 3.14, that's not an integer. Fractions are not. We already talked about. Now, if I go like this and I say equal y, this is now still a polynomial. This variable over here is not considered the variable. It's considered the function notation on this side. And so the y it's everything on the other side that constitutes the function. All right? So what you need to make sure that you realize that it's got one variable and the powers of the variables. For example, if I said 2 to the 1/4 x, that is a fraction exponent, but it's not on the variable. That is not a problem. The power of the variable, the exponent is on the variable, has to be a positive integer. Okay? So you have to have one variable, and all the exponents on the variable have to be positive integers. Okay? Ooh. Wait a second. One of my textbooks said something about non-negative integers, and I changed it to positive. If it said non-negative,
That would include 0.
and it can be 0. I can have 0, so that would not be positive. So I could have, because this over here, technically, this x to the 7 has a 0 integer on it. Mm-hmm. And so it's not positive integers, it's actually
Positive or 0.
Positive or 0 integers. So you can put that in here, positive, and so they said non-negative. All right. So let's do some classifying here. Is that a polynomial, yes or no?
Yes.
It has one variable, all x's, correct? Are those exponents on that x positive?
Yes.
Or 0 in this case, because this has x to the 0 here on that 5.
Last time y'all got that to a polynomial.
Is this a polynomial? Okay, so the criteria is it's got one variable. Does this have one variable? All x's, correct? Okay. So it meets that criteria. And then the powers of that variable, or the powers on the variable, have to be positive and 0 integers.
Okay.
So is that true? So yes, this is a polynomial. Is this one?
Yes.
What is this thing?
0.
It's a function.
It's the same. It's just the function notation, it's just saying that this is a function of x, and so this is actually telling you what the variable will be. It'll says it's x, and so you're having x's over here.
Is it a polynomial? Because it's negative 25x to the 345.
So it's the powers that have to be positive, not the coefficients in front. Okay, good questions. This one is a function, yes. Next one. Is that?
No.
I heard a no. Anybody want to? I heard some people that don't know. I only heard one person
It's
be
an
bold.
integer.
What's
It's not an
the
integer.
exponent on that x?
It's
A
zero.
-1.
A -1. Why is it a -1?
It's on the bottom of
Because
the
it's on the
fraction.
bottom of the fraction. So this is not a polynomial. If you ever have an x or the variable in the denominator of a fraction, it will not be a polynomial, okay? Because it has a negative exponent, okay? All right, not a polynomial, and we explained why, because it has that x down below. It has a negative exponent that way. All right, this one, is this a polynomial, yes or no?
Yes.
I heard yes. I heard another yes.
X has an invisible 1, right?
Oh, no, it's not.
No.
Why?
It's a variable.
Has two variables. It has x and y. It is not a polynomial because I have two variables and not one.
I'm
Okay?
gonna say yeah.
All right. So what about this one? Is this a function?
No.
I heard
You mean
no.
You mean a polynomial?
I'm sorry. Is it a polynomial?
No.
Why?
Because one of the...
Fraction.
Because the
It's a fraction.
exponent on that variable is a fraction. So we have all of those were not polynomials. This top one, the 2x, the 2 over x because it has a negative exponent. This one because we have two variables, and this one because we have a fraction as an exponent. Okay. All right. I'm giving you some more just because I want you to practice on these. I put the same definition up here again. Function that has one variable and its powers of the variable are all the all the powers are positive. We said it could equal 0 also. All right, is that one a polynomial, yes or no?
No.
No.
And that's because it has a negative.
Because that's because it has that negative exponent. That's correct. What about that one?
Yes.
Yes. What about this one?
No.
I heard no. Anybody want to make a guess?
Yes.
I heard a yes. This is a 50-50 chance.
No.
You're going to say no.
I'm not siding with Isaac, so yes.
You're going to side with Brett.
I don't know.
Okay, now, we have not, this is why I'm covering this, we have not covered what happens with the square roots, but I'm going to just tell you that the exponents for square roots are not positive integers. They're different, and I'm not going to go into it right now because we won't need it for a while, but whenever you have an x under the square root, it is not a polynomial, okay? If you had a square root as an exponent also, it would
So
not
it's
be
a no.
So it's a no. That is correct.
I changed my answer.
Change your answer. Here we go.
I was still right.
Last one, is this one a polynomial, yes or no?
No,
Because
it has a negative.
Because the
one
negative
exponent.
exponent down here on that x, when it's
Did not
below,
mean-
it's on the bottom. If the x was on the top, would it have been a polynomial?
Yes.
Yes. We can have the coefficients. These numbers in front are called coefficients, and they can be fractions. It's the exponents that we're worried about. So no. All right. All right, I have number 1, A, E, and F we're going to do together so you can see how to do it. This is on 6.2. The instructions say, are the following polynomials, and we're going to list why. You're going to circle yes or no. If you answer no, then you need to circle a reason. So I've given you a yes and a no, and the only time you'd have to give the reasons over here is if you answer what?
No.
Okay, so number 1, or A, excuse me, is that a polynomial, yes or no?
Yes.
No.
I heard no, I heard yes.
Variables.
Yes.
It's got two variables. Okay, so let's talk about that.
It's got a y equal.
The y equals is okay. It's not considered the variable. It's the function notation like the f of x. And so over on the other side, it's only got one variable. So we need to talk about that so you can make sure you got it. So good. So it is a polynomial, yes. Letter E.
Yes.
I heard yes.
Yes.
We have a fraction though. Is that a problem?
No, because the variable isn't in the denominator.
That's right, because the variable is not the one with the fraction as an exponent. So it's a yes. What about f? Is that a function? Excuse me, a
No.
polynomial? No.
Variables.
Two variables. So which one do I have? Which one do I circle? The wrong exponent on the variable or the wrong number of variables?
Wrong number.
Wrong number of variables. Okay.
Are these numbers or yes?
This is number 1 on your homework. So we answered yes on this one, yes on this one. So we didn't have to do any more if we answered yes. It was the last one we answered no, and it's the wrong number of variables. It had extra variables. So I wanted to do that with you so you know how to do these problems. Okay. Let's move on to the degree of polynomials. We're going to talk about what's called a degree. The degree, if I ask you what is the degree of this polynomial, you will look for the highest power on a variable, and you'll say it's the first degree, a third degree, fourth degree, depending on the highest exponent on the variable. Here's an example. So right here, what's the highest number on on the x variable?
Third.
So this is a third degree polynomial. And there's room for some of you who you can write it on the side over there. I want to tell you, they're not always going to just be first degree, second degree, third degree. There's actually names for them, and I'm going to give them here.
It says number of terms.
We're going to do that next, okay? All right, so if you have something that's got just this outside, that has a 0 on the exponent, right, by the way. This 5 at the end, if I just listed a 12 as my polynomial, it's the same as 12x to the 0, so it's like it has a 0 as its exponent on that power, on that variable. It would be called a constant. It would be called a constant. So if it's all by itself, just the 5 out there is called a constant. If it's got a 1 as its exponent, it's a first degree polynomial, but it's called a linear polynomial. Why would it be called a linear polynomial?
It's a linear equation.
Because it's a linear equation, and linear equations graph what?
Lines.
Lines. Let's see that little word line in there. Okay. For example, like you had y equals 2x plus 7. The 2x has a visible 1 right up there. You can't see it. And so that has a first degree, and it's a linear equation. A linear polynomial, too.
So
Second
constant
degree.
polynomial? Is that how you say that?
Say that again.
Constant polynomial?
Yes,
Constant
I suppose it would
polynomial.
be just a constant polynomial, yes.
Okay.
Now we have linear. Now second degree. We've seen second degrees. Does anybody want to guess what that one is?
Binomial.
It's got a 2 on the exponent. So let's just say it was like this. Y equals x to the what power?
Squared.
2. What kind of equation is that one? We've been doing them.
Polynomial.
It's a
Quadratic.
quadratic. There we go. A quadratic. All right. A third degree polynomial has 3 terms. Anybody want to guess? We've not done it, so it's called a cubic. Cubic. This is as far as we're going to go. We're not going to go forth and have a name. After that, we're just going to say it's a 5th degree or a 6th degree or a 7th degree or an 8th degree. So the first ones, you'll need to know it's a constant, linear, quadratic, and cubic. But after that, you'll just do 4th, 5th, and so on. Okay? Terms. The number of terms also has a way of naming them. This has 3 terms. The terms are the items that are separated by the add or subtract. So I'm going to circle each of the terms so you'll understand why it's 3. We have 1, 2, 3. 3 terms. The one we had up there was that what degree is this one?
Second degree.
Second degree, so it's called a quadratic, and it has 3 terms. So it'll be a quadratic, and we'll also name it by its degree and its terms. If it has only 1 term, it is called a monomial or a constant, and it depends. So let me give you an example. If it only has 1 term, for it to be a monomial, it's going to have a variable like 2x or 2l or 2k or something. But a constant's going to have just a number all by itself, like 5. So if it's all by itself with no variable, it's going to be called a constant. If it has a variable, it will be a monomial. And that could be squared, by the way. I could have did 2x squared. That would also have been a monomial if it's all by itself.
What?
I'm going to put a comma between it. So if all by itself you had y equals 2x squared, it would be a monomial. It'll be a second degree monomial. Okay? If you had y equals 2x squared, okay? By itself, without this little 5 there, without the 5, that will be called a second degree or a quadratic monomial.
Because there's only one x.
Because there's only 1 term.
Okay.
Okay?
Can we do some examples?
Yes, we will. If you had two terms, it's now called a binomial.
Bio.
Like a bicycle has two wheels.
That's
Binomial has two. Nomial means term, by the way. So if I had y equals 2x plus 4,
Mono means
that has
one.
two terms. And is this a monomial? No, excuse me. Is this linear, quadratic, cubic, quartic, or fourth degree, Amy?
Linear?
Linear. So this will be a linear binomial. Okay?
Why?
Because it's to the first degree right here. Invisible little one.
Well, so the 4 doesn't count as anything?
It makes it be a binomial.
Oh, it is a binomial?
It's a binomial, but it is a linear binomial because the linear part talks about the degree. So we have,
So 2x is a term and 4 is a term.
that's correct.
Okay.
Yes,
So
that is correct.
So, linear binomial? Is that how you say that? Or is it vice versa?
You can do it. I think we usually put the word linear first, and I don't know
That sounds
why.
better.
Yes, you could. Yeah, if you were on your paper said it was a binomial and linear, it was binomial and linear, I would be fine with it because if you use them like adjectives both. Okay.
Okay.
All right. So we went first term, one term, two terms. Now we're going to go to three terms. What do you think three terms is going to be?
Trinomial.
Trinomial, yes.
Those are all mono, bi, and
Try, that's right. After we get past trinomial, we're not going any further.
What about quadratic? This quad is four.
Quadratic only talks about the squared on the top. Okay. All right. So we have a trinomial. You've seen many of the trinomials. You've been factoring them. If I said y equals 2x squared plus 3x plus 4, this has 1, 2, 3 terms. So it's a trinomial. What's the degree?
Second degree.
Second degree, so we call it a what?
Quadratic.
A what?
Quadratic.
A quadratic. So this is a quadratic trinomial. Okay? All right. After we're past 3 and we go to 4 terms and 5 terms and so forth, we just call it that many terms.
Yeah, like
So most of the time, for your homework, you're going to say 6 terms, 5 terms, 7 terms. But most of the time, we'll just call it a polynomial after that. But when they're on your homework and they ask you how many terms, you're going to say 4 terms, 3 terms. If it's 3, you say it's a trinomial. If it's 2, you just call it a binomial. Anything higher than any 4 and higher, you're just going to say it's got 6 terms. Let's do some homework problems. I'm going to do number 2 and 3. Number 2 and 3. Okay, number 2. Number 2, it has how many terms?
3.
3 terms. And what's the degree?
Second degree.
Linear.
Second degree. So it's got the highest is a 2. So it's a second degree. What do we call second degrees?
Quadratic.
Quadratic. And it's a quadratic and it's a trinomial. All right? So you will write the words quadratic and trinomial. Number 3. What's the degree of that one?
6.
6. What's the name for a 6th degree?
6.
Just 6th degree, nothing special. And how many terms does it have?
4.
4. Is there a special term for 4? No. So you will write 6th degree, 4 terms. Function notation and evaluating. You have seen we've done function notation before with this f of x. This is not multiplying. This means that we will see an x as the variable on the other side, and that variable is there, and that's the only one that's there. Is this a polynomial, by the way?
Yes.
Yes, we have only x, and we have the exponents being positive or 0. And this is just the way we use this, all right? So if I asked you, you've done this before, if I asked you to find f of 3, what does that mean to do? Just put a 3 for everyone. So I'll come in here, and I will put in 4 times 3 to the 3rd, plus 2 times 3 to the 2nd, plus 2 times 3 plus 5.
And we could just put them in our calculator.
And you'll just put it in your calculator at that point. I need to see this step so I know that what you did. And that way, if you missed it, you'll know what you did. And you can go back and diagnose your issues. Okay? All right, let's do number 10. Okay, so it asks you to find g of 6. So we're going to plug that 6 in. We're going to have 6 squared minus 2 times 6. I'm going to do it out. You can do it in your calculator,
24.
but I'm going to do 36 minus 12.
24.
I heard 24.
That's what
Someone
I got as
verify
well.
that.
That's what I got as well.
24, I heard. Fantastic. Questions about evaluating this function? We've done this before. All right, now we're going to talk about something that's brand new. we're going to talk about, before you do anything, we're going to look for patterns, and you're going to help me diagnose what we call end behavior, okay? End behavior is the direction that the graph goes on both ends of it. All right, so
Yeah.
I'm going to put graphs up here, and I want you guys to help me with the patterns. I need you guys to look up here. It's really important. So you are going to look at the ends of these graphs. I'm going to bring 4 of them up here, and we're going to try and find a pattern so that you can do it by yourself. If I just tell you the patterns, if you don't figure it out on your own, I don't think it's yours, and it's something you won't remember as easy. Here we go. Here is a first-degree polynomial. It is a linear equation, and it's a line. I want you to notice this is 2 different lines, and I have a blue line and a green line. The blue line, I want you to notice, it goes down to the left and up to the right. The green one goes up to the left and down to the right. When you guys were graphing these a long time ago, what made the blue line go up? Positive slope, right? And the green? Negative slope. And it was actually on so if this was y equals 2x plus 4, it's the one with the highest exponent that determines whether it's going uphill or downhill, correct? Okay. And this is a what degree?
I'm sorry.
What's the exponent on there? A 1.
Constant?
Okay, a 1. So on a first degree, I want you to notice that the end behavior goes down and up, or up and down. Okay? Let's go to the next one up. Bringing in a second degree, which is a quadratic, which is, what do we call this graph?
What is the end behavior? What do you mean by the end behavior?
The end behavior, the end of this one goes down, and the end of this one goes up.
Oh.
What is the end behavior on these?
Up and up.
They both go up, or they both go down. What made this one go up? Positive a value, or the positive. Remember on this last one we said it was the one that actually has the degree on it. Y, in this case, it's y equals 2x squared. If that was, well, we'll get there. We'll get there. So if I have y equals 2x squared, notice that's the coefficient on the leading variable, or the one that's got the highest one, right? If it's positive, it goes up. If it's negative, it goes down. Let's recap really quick. On the first degree of polynomials, right here, the end behavior, come on, one goes down and one goes up. What happens with these? They both go up or they both go down. What about this is a third degree? I'm going to actually make it a little darker for you guys because it's hard to see. So here's one of them. Here's a third degree right there. And it's not as pointy as I made it look, but... And here's another one. Let me get a different color.
Oh my gosh, I did it. I made one of the squiggy lines.
You made a squiggly. Yes, you did. What degree was that one?
That's
All right. What's the end behavior on this one? Down and up, and the same with this one, right? Yeah. What do you think determines if it's going to start down and go up or start up and go down? The what?
Huh?
Okay, over here, what made this one start down and go up or start up and go down? A positive leading coefficient, right? The leading one, the one that has the degree. What about this one? What made this one both go up? Positive at the very first front one, right? Was positive and this was negative. So what do you think is going to make this one start down and go up?
Positive.
It's going to be a positive. What would it look like if I was going to have a negative in it? It's going to start. It's going to start up and go down, right?
Yeah.
Okay. This is a fourth degree. Let me give you 2 examples of a fourth degree.
Oh my gosh, my brain is spinning.
I'm going to draw this one.
Golly.
And here's another one down below. Make it a little darker for you. All right. What do we know about this one?
Not a dang thing.
They're both up or they're both down. Did we have any others that were both up and both down?
Quadratic.
A quadratic. And so the linear were opposite.
So the odd.
We skip count this thing.
Yeah.
We have 1, 2, 3, 4. I gave them in order.
Yeah.
Okay. So these ones have opposite. The
odd numbers.
The odd numbers go
up and down.
And the
The
even ones
are
together. So there is a pattern, and we found the pattern for the end behavior. If the degree is odd, 1 or 3, the end behaviors will be rising and falling of the ends, right? They won't be the same. If it's an even degree, they will both be together, either both rising or both falling. Let's do some examples so you can see what we're talking about, okay? Here. This is a 4th degree polynomial, number 14. Are they going to be together or opposite? Together. Are they going to go up or down?
Down.
Okay, so you need to do this. On all of these, you're going to write the words left and right.
Why?
I just do LR.
You can.
That's what I'm gonna do.
See, we determined, is it going to rise or fall?
Fall?
This is both going to fall, right?
Yeah.
Both on the left, so we just write fall. So on the,
Why is it gonna fall?
As is.
okay, so we determined that it was an even, right? 4 is even. So that means they're together. They're either going to be going both up
So they're
or
going
both
the same
down.
thing.
How did we decide they were going both down?
Because it was a negative.
Because the negative on the 4th degree.
Okay.
So from the left it falls and to the right it falls.
Okay.
It's going to go down on the left and right. Okay?
That's
All right, what
really
about 15? Is that going to be, we have to write a left and a right,
Opposite.
correct?
good. So
It's going to go left and right. We always have to write that part because, now is this going to be both together, up and down, or is it going to be opposite?
So rise
Opposite.
and
Okay,
fall.
so it's going, and I have to actually do this with my hands. It's going uphill, right? So it's like this.
So yeah, left will be down.
So
and
left will be down, and right will be,
So right will be rise and left will be fall.
so it'll be
I'm
like,
so gone.
here, I'm going to give myself a graph. All right, positive just goes like this, correct? That's when we're doing linear, right?
This might actually help me to type in the calculator.
So,
left will be
is this the left or the right, Isaac?
That's left.
Is it going down or is it rising or falling?
Down.
Falling, so left is fall.
Okay.
Why did I draw that?
To help us understand it.
Because it's a positive, and positives go
Oh,
uphill.
Right.
There could be some squiggles in the center. I don't care about the squiggles in the center. I just want the ends, okay? I just want the ends,
And then
Snake.
divide it up.
yeah, I forgot.
okay?
That looks like a shirt you would wear.
So it's going to, on the left it's going to fall, and on the right it's going to rise. All right, let's do this one. This is not new. This is review, but these are 2 polynomials. Just for our review's sake, this first one here is, what kind of polynomial is that? What's the highest degree on that first one? 3rd degree, so it's a
Fine.
cubic,
Quad.
2 terms,
Quadratic binomial?
not a quadratic.
I will relook
Cubic?
at this.
Cubic,
Binomial?
not cubic binomial. Cubic binomial, all right. What about this one over here?
Cubic trinomial? Cubic.
Oh, is this a trinomial? Is this a cubic? Is this cubic?
Yeah. That's
Yes, because this guy's the highest, even though it's not in the front. This is a cubic, and how many terms does it have?
Trinomial.
Cubic trinomial. Very good. Okay, so we're going to add
Wait, are
these.
those on something? Where?
This is number 20 on your paper.
Where are they now?
All right, you didn't have to write any of that part down. That was just review. We're going to add these. To add these, all we do is add like terms. That's all. So what goes with the 8
Find it right now, my guy?
x
No, I'm
cubed?
like,
What goes with 8x cubed?
The 3x.
The 3x cubed. Okay, so what does that become?
11x cubed.
I'm going to change colors. I've got negative 4x squared and 7x squared.
So
3x squared? Minus 4?
And then minus 4. You're done. All right, now we're going to do the difference. Difference means subtract. Now be very cautious with subtract. So when we subtract, I am going to suggest you do this. I am going to suggest that you actually distribute that negative and add. I'm going to suggest that you turn this to a positive and these all to the opposites of what they originally were. And then just do the adding of like terms after that.
So just
I
writing
don't
those
get
3 little
video.
lines is the equivalent.
I made that a
Distributing.
positive, which made that one a negative, that one a positive. All right. So all we're going to do is distribute that negative to everything. And now we're going to combine like terms.
So would that be negative a squared?
What's the a cubed go with?
the 7a cubed?
The 7a cubed for a
Negative
total
squared.
of.
Where'd you get that from?
Negative a squared, not 8.
No, I heard you say a squared.
So what does this become? How many a cubes do we have?
8 to the
8.
3rd.
8 to the 3rd. What about the 7a squared?
It's a negative 7a squared.
Negative 7a squared.
So
And
plus
a-
this positive 6a squared.
And that's a negative.
I'm on 23. That
Minus.
explains why I'm getting
That's
Oh,
a
that
negative.
is a negative.
So
A
negative
squared.
13a cubed.
Yes, negative
I mean, squared.
13 to the 3rd and we have something left over.
Why
Wait,
did
why
you
to the
get
third? Isn't it to the
13?
second?
Yeah, how'd you get to the 13?
Because I'm wrong.
How'd you get 13?
Because that's a negative
7
Because
plus
this is a negative 6 and a negative 7 make a negative
Oh, that's
13.
right. You make the 6
Yep.
a negative.
Okay.
Yeah, I did the
Good questions. Good questions. What else do I have left
Then
there?
you just do plus
2a
2 and 4.
Plus 2a to the 4th.
Yay!
This is what we did this lesson. You learned what a polynomial was. If it's you got learned what it was and how to identify it. You learned some vocabulary for the degrees and the number of terms. You learned about the end behavior and you learned how to substitute in. And then we learned how to do adding and subtracting. Your assignments, I'm just going to warn you, are a little longer this week because you're going to be studying for your final. All right? So they're long. That's why there was tons of printouts this week. Okay? All right.